Next is modern periodic table. So after the discovery of atomic number, now it's more easy to arrange elements in order of their increasing atomic numbers, because atomic number is equal to number of protons. And as in case of atomic masses, any element can be placed between two consecutive atomic masses, but that's not true for atomic number. No an element can be placed between any two atomic numbers. So as per Bohr-Bury scheme, this will do in detail in second chapter, atomic structure. Three rules are given for writing electronic configuration, which you have done in your last lecture of chemistry. What do you mean by electronic configuration? Gaurav sir has told you regarding s,p,d,f orbitals and how many number of electrons you can fill, like in s2 electrons, in p 6 electrons, in d10 and in f 14. So they are basically present on the basis of these three rules. First one is Aufbau rule, which is also called as N plus L rule, Pauli's exclusion principles, and Hund's rule. These rules will also do in detail in second chapter, that is atomic structure. Now here are energy order of orbitals for filling of an electron, that are 1s2, 2s2, 2p6, 3s2, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6x, f4, f, 5d, 6p, 7s, 6d and 7p. This you can learn easily from that table which you have done in last lecture, that 1s, 2s, 3s, 4s, then 2p, 3p, 4p. Why? By this way, which are cutted over from upper to lower side for that table, you can easily learn that what come after this, or these are the energy level orbitals in which each increasing energies, they are filled in order of their increasing energies. So in modern periodic table, it consists of 7 horizontal rows which are called as periods. You can see here 1, 2, 3, 4, 5, 6, 7. So these all 7 periods and 18 vertical columns like this. They are called as groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So this is periodic table which is divided into 7 periods and 18 groups. So these are further divided into blocks. Like first 2 groups, they are divided into S block elements, and these are from 13 to 18, they are called as P block elements, and these S and P block, they are also called as representative elements. You can see here also group 1 and 2, they are called as representative elements, and from 13 to 12 they are called as D block elements, and they are also called as transition elements. Later on I'll give you detail that how you can easily learn groups. Like for group 1, I'll give you one trick for every group and for every period from left to right, how you can learn this periodic table. I'll give you tricks for this periodic table. And you can see here below this D block or these transition elements, there are 2 more groups which are called as lanthanides and actinides. So these are lanthanides which were from 58 till 71. They are called as F block elements or inner transition elements, and below this lanthanides you can see here actinides which started from thorium, whose atomic number is 90, till 103, which is lawrencium. So this is all about periodic table. Now using this table, that is long form of periodic table was formulated, and here I have written electronic configuration of elements for group 1, that is you can see here for lithium, whose atomic number is 3, it's 1s2, 2s1. For sodium, it's a 3s1. For potassium, it's 4s1. So you can see here where I have circled these 2s, 3s, 4s, 5s, 6s and 7s with circle. So what I have tried to show here, that each regular interval these properties are repeated, or you can say that these repetition of properties, they are called as periodicity, which was explained only by modern periodic table, which was given by Henry Moseley. So after this, we'll see that how many elements are present in a period. That according to Bohr-Bury theory, orbital energy order for filling an electron is this one, which right now I have told you have to learn this order. And because there are 7 periods in modern periodic table, so with this short trick we can learn how many elements are present in a period. Like for if period number 1, number of elements they are 2, and this one is the shortest period. And in period number 2, number of elements are 8, in 3, 8, 4, 18, 5, 18, 6 and 7, 32, and this 6th and 7th one are the longest period. How you can learn that this one is period number 1, here only hydrogen and helium is present. Then in group 2, period 2, this one is 8, 1, 2, 3, 4, 5, 6, 7 and 8. 8 elements are present, and then 8, 18, 18, 32 and 32. Now, what are the merits of modern periodic table? He has explained the periodicity of elements, and he arranged the periodic table into the group of 4 blocks, that is S block, P block, D block and F block. So now what are the demerits? That position of hydrogen is still not explained, and he is not able to explain position of lanthanides. And next comes classification of modern periodic table based on blocks. Now modern periodic table is classified into 4 blocks, that is S, P, D and F block. The name of these blocks, they are derived from the name of orbital which receives the last electron. Like for S orbital, maximum 2 electrons are there. You can see here in group 1 only 1 electron is present, and in group 2 2 electrons are present. So maximum 2 groups are there for S block element. And for P block, in P orbital maximum number of electrons are 6, so that's why P block elements occupy 6 groups. You can see here 1, 2, 3, 4, 5 and 6. So there are total 6 groups of periodic table who belongs to P block. Next is the D block. Now D have 5 orbitals, that is dxy, dyz, dzx, dx square minus y square and dz square, and each orbital occupy maximum 2 electrons. So if 5 d orbitals are there, then maximum electrons are 10. So that's mean d orbital have 10 groups in periodic table. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these 10 groups belongs to D block elements. And F orbital, they have 14 groups. You can see here, because F have 7 orbitals, and total in one orbital if it occupy 2 electrons, though, so that in 7 maximum number of electrons are 14. So you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So total 14 groups belongs to F orbital, whose position is below inner transition, means they have got no place in the periodic table, and below transition elements, these F block elements are called as inner transition elements. And his first series is lanthanide series and second one is actinide series. Now we'll do electronic configuration one by one. First belong to S block element group 1, that is called as alkali metal. First member is hydrogen, configuration is 1s1, then lithium 2s1, sodium 3s1. So you can see here last electron enter into S orbital. So that's why it's S block element. And what's its valency? Its valency is 1 because 1 electron is present in valence shell. This also you have done in your 10th standard. Then group 2, they are called as alkaline earth metals. Beryllium, configuration 1s2, 2s2. Magnesium, atomic number 12, configuration is last one is 3s2. Then next calcium, atomic number 20. Try to write these configurations yourself. Its configuration last ends at 4s2. So now what's common in this? Each valence shell has 2 electrons each. That's why it belongs to group 2. Now you can write here journal configuration of group 1 is NS1 and journal configuration for group 2 is NS2, and you can write journal configuration for S block elements is NS1 to 2 because S orbital can occupy maximum of 2 electrons each. Now next comes P block. First is group 13. Boron is the first member, atomic number 5, 1s2, 2s2, 2p1. Aluminium 3p1, gallium 4p1. Or in journal we can write what is the journal configuration for group 13, that is ns2np1 because each element occupy S orbital 2 electrons and last p orbital occupy only single electron. For group 14 now it becomes 2p2, 3p2 or 4p2. So till p orbital occupy 6 electrons each, then each electron enter into p orbital till group 18. Like here group 15, now third electron enter and its configuration will become 2p3. For phosphorus it is 3p3. For arsenic it is 4p3. Then for group 16, oxygen, atomic number 8, configuration 1s2, 2s2, 2p4. I have written here so many examples for group 13, for group 14, for group 15, for group 16. Similarly, on next page, I have written for 17 and 18 along with their journal configuration. Now you can see here comparison. Journal configuration for group 13 is ns2np1. For 14, ns2 np2. Now one electron enter into p orbital. Next for group 15, next electron enter into p. Yani now if it is np1 in 13, np2 in 14, np3 in 15. Now for 16 it becomes ns2 np4. And similarly for next, that is for group 17, now it becomes np5. For group 18 it becomes np6. So I have written journal configuration with examples from group number 13 to 18, or in short I can write here, or I have written here, journal configuration for p block is ns2 np1 to 6. Now I think it's clear to you what's the meaning of 1 to 6. Same way I have written journal configuration for D block, that is n-1 D1 to 10 ns2. So why it's written D1 to 10? Because the same way as we have filled for P, 2p1, 3p, 2p2, same way we'll fill 10 electrons in D, starting from scandium whose atomic number is 21. You can see here, to zinc whose atomic number is 30. You can see here in scandium its configuration is 3d1, then 3d2, 3d3. For chromium it's 3d4 and so on till zinc it's 3d10, 4s2. So its journal configuration for D block. Similarly, for F block elements, its journal configuration is N-2 F1 to 14 NS2. So these journal configurations, they are very, very important for your CBSE exam as well as for your NEET exam and for JEE exam. So now I have fully explained to you till modern periodic table. Now we'll try to solve questions which have come in your JEE and NEET exam. So this one is first question, that is the element with electronic configuration. The element with electronic configuration as argon 3d10 4s2 4p3 represents either a metal, a non-metal, a metalloid, or a transition element. Now you can see here, you can count number of electrons. Argon is 18. So 18 plus 10 plus 2 plus 3. It becomes 18 plus 10, 28 plus 2, 30, 3, 33. Now this electronic configuration shows that p orbital of element is not complete. It is 4p3. In p orbital, maximum 6 electrons can occupy. So it's clear that it's a p block element. And moreover, the atomic number of element is 33. It means it's a metalloid. So we'll take here at metalloid. This question has come in 2010 Kerala CET because it's a common entrance test. At that time, different states have different entrance tests. Now it becomes a single test, that is NEET, that is National Eligibility Entrance Test. Now we'll move to second question, that is, what does the electronic configuration 1s2, 2s2, 2p5, 3s1 indicate? This is the question of 2010 Gujarat Common Entrance Test. Now means you have to tell this configuration belongs to either ground state of fluorine, either excited state of fluorine, either excited state of neon, or either excited state of oxide ion. So first we'll count number of electrons, that 2 to 4, 5 and 1 is 10. It means that belongs to atomic number 10. Now first of all we'll see which option is wrong. Atomic number is 10. So you know fluorine atomic number is 9. It means it's not a excited state of fluorine. Means if I will write here configuration for fluorine 1s2, 2s2, 2p6, no 2p5 because it's 9. So 5 to 7 to 9. If it is the ground state configuration, and if we'll write excited state means one electron jumps from p orbital into next 3s orbital. But we have seen here that total number of electrons are 10. So it should not be fluorine. It means B is not the answer. Now because total number of electrons are 10, so it means it's belong to neon. And this one also here it's written that 4 and 5 9 and 1 10. It means neon. Otherwise its configuration is fully filled, that is 1s2, 2s2, 2p6. And if one electron excited from 2p, then it comes to excited state, then its configuration becomes 1s2, 2s2, 2p5 and 3s1. This one is excited state configuration for neon. So what is the answer? That one is third one is answer, that is excited state of neon. I hope these two questions are clear to you. If it's not clear, anytime you can ask, you can message me or you can call me personally. Then we'll try to do this Third question, which out of the following ions has electronic configuration argon 3d6? This is noble gas configuration. You will learn in your next lecture what is meant by noble gas configuration. And atomic number I have given here: for manganese 25, for iron 26, cobalt 27, nickel 28. And I have written here ions, that is cobalt 3 positive, nickel 3 positive, manganese 3 positive, and iron 3 positive. First I'll start with cobalt, that is cobalt atomic number is 27. And if I'll write its configuration, it becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d7. Or short configuration means in case of noble gas, you can write here argon 18, 4s2, 3d7. You have to write now for cobalt 3 positive means it's cation, so we have to minus 3 electrons from atomic number, so it becomes 24. Means I have to write now configuration for atomic number 24, so it becomes cobalt 3 positive. As you have filled first s orbital, so when we have to remove electrons, that they removed first from s orbital, that is according to electronic configuration rule. So I'll write here argon 18, 4s0. You can write if you have any problem. So 2 electrons are removed from this and 1 from this, so it becomes now 3d6. So that is this much they have asked, ki which one of the following ions has electronic configuration argon 3d6. So at first we come to know that it is first one, that is A, which is CO3 positive, cobalt tri positive, whose configuration is argon 18 3d6. Same way you can try for others also. You cannot get 3d6. Thank you.